Hello class, this is Miss Ayo with today's video on 10.3 combination of functions. As you're watching the video, please feel free to pause, rewind, and repeat as much as you need. Don't forget to write down important vocabulary, formulas, equations, or statements. And at the end of watching the video, summarize the video and submit that summary via the online whisk as well as a top question the night before class. Alright, let's begin. This actual topic is super easy. We're talking about combination of functions and combining functions by either adding, subtracting, multiplying, or dividing, which in itself is not difficult and something you've done plenty of times before. But in this unit, it's actually a different spin. We are actually using mathematical models to describe and help us solve real-world situations and problems. So let's take a look at an example problem. Let's say that you are in charge of planning for, let's say you're the president of the country, and they come to you and say, we have an issue. We think that we're going to run out of food. Okay, well, the question is, when are you going to run out of food? Are we going to run out of food now, or are we going to run out of food in the future? And so they show you two different equations, a population equation that represents the population of the country in years. And then they give you another equation that represents the number of people that the country can feed in a particular year. Okay, and that's based off the amount of food supply. So in order to determine the idea of when we will have a shortage, you first need to have an understanding of what it means to have a food shortage. Does it mean that the number of people that you want to feed, you won't be able to feed that many people compared to your population? Well, in order to determine that type amount of shortage, we need to subtract the two functions from one another. So the yellow function is the population function. It's exponential. It's increasing rapidly, but the number of people that we can feed is actually increasing as well, but it's increasing at a linear rate. So at some point we are going to reach a shortage, and in order to figure out that shortage, you can either do one of two things: figuring out where the population is equal to the number of people that the country can feed in a year, and then after that would mean that we no longer will be able to feed everyone in the country and we will have a shortage. And as you can see here by the graph, the shortage appears somewhere around year 78. But another thing is we can actually take a graph of doing a simple operation of subtracting the number of people that the country can feed. We're subtracting from that amount the population, and so as a result, this is that graph here, and it gives us different x values, but these x values doesn't give us shortage. This x value gives us the maximum surplus, and this x value gives us when we will have a shortage, i.e. no surplus, which is around 80, which is consistent with this example. Okay. So we basically did a combination of functions by subtracting two functions. We subtracted p from n, and we get another function s, and that represents the shortage function. And as we said, that shortage occurs when you can't feed the number of people in your population, and so that occurs when your s function is less than 0, which is when the number of people that the country can feed minus the number of people that's in the country is also less than 0. So let's actually take a look at what it means by the amount of shortage that we're talking about. And in this case, we have surplus. In this case, this is when we have more than enough food to feed the people living in the country. And how much more food do we have? Well, that's the surplus, the amount of extra food that we have. And as you can see, we have these hard vertical lines that indicate the amount of difference. And as you can see, we have our largest surplus right around here, around time year equals 40. But then the surplus starts decreasing till we get to a point here where now we have no surplus and we have a shortage. We can represent that same thing instead of looking at two different functions and the relationship between the two functions, just considering the one function, which is the surplus function. And as we can see here, the surplus function is increasing, and right until we get to 40 is when it's its highest, but then it starts decreasing. So the information given from this graph gives us the same information given from this graph, even though this graph only graphs the population and the food supply function, and this graph only graph's a surplus because it's based off of those two. Let's take a look at a totally different example, and we have these two functions, f of x, which is x, and g of x, which is equal to 1 of x, and we want to add the vertical distances on the graph. In other words, add up the function values till we get to see what happens for x being greater than 0. And I know predicting what the graph will look like, we will see, well, x is always increasing and 1 over x is not always increasing. So it's going to be positive because x is greater than 0, but how else is this going to look? Well, we can look at a table of values, just plugging in different x values and seeing how will it affect our h of x function. And as you can see here, as our x values increase, our h values seem to decrease, then increase again, right around this one point. Well, let's see what the graph will look like. Now, this graph represents our x function, as you can see here, f, and this graph represents our g function, as we can see here. It's decreasing and they're both positive, but when we actually add them together, we end up with our h function, which looks something like this, which means that as our graph x values increase, our h of x values end up getting closer and closer and closer to the function f of x, which makes sense because as x values increase, g of x gets closer and closer and closer to 0, as we can see. Now let's look at what happens when we can multiply two functions together. And you've probably used this, you just don't know when. So let's say I want to find all the values, the zeros of this function. It looks kind of complicated. And your first sense is to factor, which means to take out common terms. So we factor out a 2 to the x, since that seems to be common in each of the terms. And then when we're left here, we can factor this trinomial into power 2 binomials, and we end up with something like that. So whether or not you know it or not, you've actually been dealing with combined functions in your previous math problems. So in order to solve this difficult problem, we can solve it by easily solving these simple problems, because by the power of the 0 property, when a function has a component that reaches 0, then the whole function is 0. Well, 2 to the x will never be 0 because it's that exponential function. 2x plus 1 will be 0 at some point, and 3x minus 2 will be 0 at some point. So our solution to this difficult looking problem can be found by breaking it down into simpler problems that we can easily find the solution for. And as you can see here, our solutions is x is equal to -1/2 and 2/3. And you can plug it in to see when we actually find the zeros of the function. Now let's take a look at another way of defining prosperity. Instead of just in surplus like the previous example 1 did, we're taking a look at a different way. So if you remember, we still have our n of t, which is our food supply function, and our p of t, which represents our population function. And before, we subtracted p of t from n of t to get our food surplus. But now let's see what happens when we divide the two. So this is a quotient of the two functions, is when you divide something. And we're going to name that function r of t. So at the 25th year, if I want to figure out what r of t is equal to, I just evaluate n at 25 and p at 25. And that number is around 3.1. But what does that number represent? It represents how much of a surplus we have, that we can feed around 3.1 people. More people than we could. So shortages is when r of t is less than 1, and surplus is when r of t is greater than 1, because that means we can feed more people, more than one person. Shortage is when you can feed less than one person. Okay, and that shortage will only occur when n of t is less than p of t. Same thing when we receive, the same thing with the surplus. The surplus is 0 when you have n of t less than p of t. So here is this graph, and as you can see here, we reach a maximum point, but then it starts decreasing right around, and it gets to 1, which is, remember when we said we actually have food shortage, and that when it gets to 1 is the same number, around 80, that it was in the previous problem, so it's consistent. Another way of looking at surplus. The last example is talking about crime and how we can use the combination of functions, more specifically quotient of functions, to get a better understanding of crime. Now here we have two cities, City A and City B, and this table gives us the number of violent crimes committed each year in each of the two cities. And off the bat, you can say, well, City A is pretty violent because they have considerably more crimes than City B, and it seems like the numbers of crimes are increasing. So you would think City A is really violent, but you don't know the whole story. You have to take into account the population of the two cities. And even though City A has a higher number of crimes each year, they also have a higher and a greater population than City B, which makes sense. But still, which city is more safer or which city is more dangerous? Well, in this case, we would use the quotient of the two crimes, of the number of crimes versus the number of people to compare. So R sub A of T gives you the ratio of the crimes per person for City A, and R sub B gives you the ratio of crimes per person in City B. And so that is a better indication of how dangerous a city is. So when we actually calculate the information, we see that City A, even though it had a higher crime rate and more people, it had higher crime number and more people, it actually has a lower crime rate than City B, which means in all intents and purposes, you'll have a higher probability of experiencing crime in City B than City A in each of these years, because in each of these years, the numbers in comparison are different, and the larger number being the crime rate for City B. And as you can see here, actually, that the crime rate for City A is decreasing. It's not as dangerous as the years go on. And that's because even though the number of crimes is increasing, the population is also increasing. So the ratio is different. So in conclusion, we use combination of functions in the real world to get a better understanding of real life situations and discovering and analyzing different situations. Okay, that's it.